Hello, everyone. Today we're going to go over the last skill in the statistics and probability unit, which is called comparing distributions. So basically, this skill, you're going to be given charts and tables and graphs and histograms and things like that. And it's going to ask you questions about the data being presented. And you're just going to have to select which answer choices are the best answer choices based on the data provided. So let's do a few examples together. The first one says the histograms below show the heights in meters of the tallest buildings in China and the United States. Which pieces of information can be gathered from these histograms? So my suggestion is to go through all your answer choices and just kind of apply them to the graphs being presented to see if they are truthful or not. Notice it does say choose all answers that apply, so there could be more than one answer here. So we have this histogram. The first thing you need to look at is what your y-axis is showing you. And we can see that the y-axis is the total number of buildings, and our x-axis represents the height in meters. So I'm just going to label those so we know which ones I'm referring to when I refer to them. So it says the US has the tallest building of these two countries. Well, we know the height is on our x-axis here. So I can see that the US has one building that's over 540 meters, whereas China does not. So A would be true. Yes, the U.S. does have the tallest building of these two countries. Let's take a look at B. China has more buildings over 390 meters tall. So first I'm going to just erase that piece there, and we're going to take a look at the ones that are 390 or taller than 390 meters. So that means that we're looking at this column, and this column. So I can see that if this is 5, that's going to be approximately 3 buildings. This looks like approximately 4 buildings, and this looks like approximately 2 buildings. So that means that China has a total of 9 buildings that are over 390 meters. Taking a look at the US, we're looking again at the same columns. So it looks like they have 1 here, 0, and then another 1, which means they have 3 total buildings that are over 390 meters tall. So B would also be correct. Yes, China does have more buildings over 390 meters tall. So in this case, both A and B would be considered correct answers. Let's take a look at this one. The Baltimore Ravens won the American Football Championship in 2013. In the same season, the Kansas City Chiefs had a record of 2 wins and 14 losses. The dot plots below show the 40-yard dash times in seconds of the defensive backs on each team's roster. Defensive backs mainly defend against passes, and the 40-yard dash is the main measure of speed used in American football. Which pieces of information can be gathered from these dot plots? Remember that the lower 40-yard dash times are faster. Okay, so the dots that we see here early on, those are going to be your faster time. So just keep that in mind. Again, this says choose all answers that apply, which means that there could be more than one answer choice. So we've got the dot plot. Let's take a look at answer choice A. Says the defensive backs on the Chiefs are faster on average. Well, taking a look, their dots are a lot further back, which means their times are slower. So it's not going to be A. That is not a true statement. B says the speed of the defensive backs on the Chiefs varies noticeably more than the speed of the defensive backs on the Ravens. Varies noticeably more. That's something you're going to see in these questions. What that means exactly is how spread out is your data. I can see my first point is right there, and my last point is right there. So that means that the data is spread out between your first point and your last point. Taking a look up here, I can see that my data for the Ravens is actually way more spread out than the Kansas City Chiefs. It's spread out over a wider length of time. So B would also be incorrect, because if it had said the speed of the defensive backs on the Ravens varies noticeably more, then that would have been a true statement. But because they're saying the Chiefs, that is not true. The Ravens definitely varies noticeably more than the Chiefs. So in this case, C, none of the above would be the correct option. Okay, before we get into a few more questions, let's just review about what a box and whisker plot is. Sometimes they're referred to as box plots. You will see some of these graphs in these problems or in these this skill. So I just want to review some of the terms for a box plot and what exactly it means. So this right here is a basic diagram of a box plot. Here we can see we've got our minimum or lowest value, and then obviously at the farthest right side is your highest value or your maximum. Now, the median, remember your median is your middle number. So if you were to take all your data and arrange it from least to greatest, the median would be the middle number in that data set. So your median is going to be that line right in the middle of your box. And then your lower quartile and your upper quartile, sometimes referred to as Q1 and Q3, are going to make up the ends of your box for your box and whisker plot. So we've got our median, our lower quartile or Q1, and our upper quartile or Q3. So what exactly is a lower quartile? That's just the median of the lower half of your data set. So let's maybe do a quick example. So let's say I have a data set of, let's do 5 numbers. Let's do 1, 2, 2, 4, and 5. Okay, so my median would be my middle number. So 2 would be my median. So I'm going to start my lowest value would be 1. My highest value would be 5. So I'm going to draw my box and whisker plot. So let's go ahead. We'll do 2, 3, 4. Okay, so my median is going to be 2. Whoops, let me just erase this. So my median is going to be 2. I'm going to put a line there. And then your lower quartile is the median of the lower half of your data set. So the lower half of my data set would be these 2 numbers, and your median is your middle number, or that would be the average of your lower half of your data set. So if I were to find the average of 1 and 2, well, 1 plus 2 is 3, and 3 divided by 2 is 1.5. So that would mean my lower quartile would be at approximately 1.5, which is right in between 1 and 2. And then my upper quartile would be the top half of our data, which is 4 and 5, which obviously your middle number there would be 4.5. So I'm going to draw, excuse me, another line there, which means my box is going to look like this. And then I'm just going to connect it. That's what the whiskers are, these connecting points. So you've got your lowest value, which is 1, your highest value, which is 5. My median was 2. And then my Q1, or my lower quartile, was the average or the median of my lower data set, which was 1.5. And my Q3 was the median of the upper half of my data, which was 4.5. So if I were to make a box plot based on the numbers I gave you, 1, 2, 2, 4, and 5, that's approximately what it would look like. And the last one is your interquartile range. Your interquartile range is the spread in the middle 50% of the data values. That's just your Q3 minus your Q1. So if I were trying to find the interquartile range for this data set we just did, well, my upper quartile was 4.5. My lower quartile was 1.5. So my interquartile range would be 3 in this case, because it ranges between 1.5 and 4.5. Okay, so that's the basics for a box and whisker plot. So let's take a look at a few examples where you kind of just have to understand what's happening in your box plots. It says macaws are tropical birds that can live a very long time. The box plots below show the lifespans in years of a random sample of macaws that lived in captivity and a random sample that lived in the wild. Which pieces of information can be gathered from these box plots? Choose all answers that apply. Again, there could be more than one answer here. So it says, on average, lifespans were longer for macaws in the wild. Well, let's take a look here. You've got in the captivity on top and then in the wild on the bottom. So if you look at the lifespan, it ranged anywhere from approximately 32 years to approximately about 78 years. So the lifespan in the wild was about 78 years, whereas the lifespan in captivity was about 66 to, what's that, 84. So that's about 18 years. So the lifespans ranged from 66 years to 84 years, whereas in the wild they range anywhere from only 32 years to about 78 years. So on average, the lifespans for the macaws were longer in the wild. No, that's not true. They lived longer when they were in captivity. They lived, most of them, at least 66 years and anywhere up to 84 years. So A is incorrect. The lifespans for all the macaws in captivity were longer than those in the wild. Well, notice it says for all. And as I can see here, this part overlaps with this part. So that means that it isn't all of them because there is an overlap. So B would be also incorrect. C says the lifespan for the macaws in the wild varied noticeably more. There's that varied noticeably more that we saw earlier. So I'm just going to underline that. Let me just erase what I have here. So they're saying the lifespan for macaws in the wild varied noticeably more. Well, yes, if you look at how spread out the data is here compared to how small it's spread out in captivity. So in this case, C would be the only correct option. Yes, the lifespans for the macaws in the wild varied noticeably more than those in captivity. Okay, the box plot below shows the heights in centimeters of players on the University of Maryland women's basketball and field hockey teams. Which pieces of information can be gathered from these box plots? Choose all answers that apply. All right, so we've got basketball on top and field hockey on the bottom. You've got your height in centimeters here, so we can clearly see that most of the field hockey team is definitely on average shorter than the height of the basketball team players. But let's take a look. Again, we have choose all that apply. The basketball players are taller on average. Well, yes, that's true, because if you look, remember 50% of their data falls within this box, which is your inner quartile range. So yes, the basketball players are taller on average. B says the heights of the basketball players vary noticeably more. There's that term than those of the field hockey team. Well, look at how much more spread out your data is up top. So yes, it does vary noticeably more. So in this case, both A and B would be considered correct. All right, let's try one last one together. People seem to like movies about comic book heroes. The histograms below show the gross revenue and hundreds of millions of dollars in movies based on heroes from the two most popular comic book companies. Which pieces of information can be gathered from these histograms? And again, we've got choose all that apply. So up top, we've got Marvel Comics. Down below, we've got the DX Comics. And again, we're just going to have to go through the answer choices to see which ones make the most sense based on the data provided. A says movies based on Marvel heroes bring in more money on average. Well, on your y-axis, you've got your number of movies, and on your x-axis, you've got hundreds of millions of dollars. Okay, so let's think about this. So this would be 7 movies making $100 million. So that's 700 million. Okay, we've got, let's just count how many movies. We've got 7, 15. We've got 3. Oops, that should be a 3. Write that so you can see it a little bit more clearly. Here we've got 4, 2, and then 1 here. So we've got 15 plus 7 is 22, plus 3, that's 25 movies, 29, 31, 32 movies that are bringing in hundreds of millions of dollars. And here we've got 11, 7, 4, 1, and 1. So that's 19, 23, 24, 25 movies bringing in money. So if you take a look, clearly the one that has the more movies is going to be bringing in more money on average. We could add up how much total money it is, but I can see just between these these first two columns in the Marvel movies that you're definitely going to be bringing in way more money with the Marvel comics than the DX. So movies based on Marvel heroes bring in more money on average. That would be true. B says all Marvel movies bring in more money than DX movies. Well, that's not true, because if you look, DX has some here that are bringing in they've got one movie bringing in $500 million, and they've got one movie bringing in $600 million. So it's not all of them, so it can't be B. The amount earned by DX movies varies much more than the amount earned by Marvel movies. Well, if you look at how the data is presented, it's in these histograms. So the data is only spread out between 0 and 600 million in both of these histograms. So there's no way to show that the data is varying noticeably more, because both histograms are showing the same range. So C is not true, which means that the only correct option here that would work would be option A. Movies based on Marvel heroes bring in more money on average. So as you can see with these problems, it's really just analyzing the data being given to you, whether it's in a dot plot or a box plot or in a histogram or in a bar graph. You really just have to look at the data and then read through your answer choice options to see which ones are the most accurate based on the data being provided. So the correlating note-taking packet pages are pages 17 and 18. And again, if you'd like to see some additional examples, you can watch the video in Khan Academy. Have a great day, everyone.